In this video, we're going to look at deductive reasoning in our logic unit, and deductive reasoning is actually one of two types of reasonings we use. What we've been using lately, and what's very common for us, is called inductive reasoning, which is based on what we see, what observations we have, patterns that we notice, just general experiences that we have happen. And that's where we would form conjectures. And conjectures are just educated guesses, remember, kind of like a hypothesis, where it's something that you think is true, but we don't necessarily know whether it is or not because it's just based on observations we've made. So we have that limited scope. And with those statements, what we have been practicing is classifying them as true or false. And remember, true would mean that the statement is always true. There's never a case where it is untrue that we can think of. And false just means that it's not a guaranteed truth. If we can think of just one example, any example where we disagree with the statement that's made, that's what our purpose of false will be. So inductive reasoning, it's a great skill to have. It's a great thing to use, but it's not what we're going to use to form formal arguments, which is what we're going to get into as we go throughout the unit. So deductive reasoning isn't solely based on observation, but rather on knowledge that we know has to be true. So what we're going to be doing here is looking at scenarios and trying to prove that something has to be a certain way based on information that we either know or information that we're given. So it's kind of like applying rules of geometry, rules of things that we know apply to the situation. So rather than guessing whether or not something can be said, a claim can be made, it's going to be very methodical to where we use either definitions or postulates of things that we know, or theorems that we have shown to be true. And theorems are just ideas people have had, and they have proven them at some point, and so now it's okay for us to use them. So that's where we're going to end up going is today, just kind of get an intro to how this deductive reasoning works. When is it okay to make a certain claim and when is it not? So this whole idea of what can we say and what order we might be able to say it in, and what cases is it where maybe it could be true, but it's not a guaranteed to be truth. So a couple cases right here, just a recap from last time. We looked at different cases of these conditional statements where we had the conditional that goes from P to Q, if you remember that, and the contrapositive, which starts with the opposite of Q and goes to the opposite of P. And what we ended up saying was, even though these things are written in a different way, with the way they're presented, they actually mean the same thing. So their overall meaning is the same. And we had a word for that, a phrase for that. We said that these are logically equivalent. Okay. And that's true for these two cases. It's also true for the other two cases where we have the converse and the inverse. And the converse started with the letter Q, the theme of Q, and ended with the theme of P, while the inverse began with the opposite of P and ends with the opposite of Q. And just like the other case, the converse and inverse are also logically equivalent. And if you've forgotten what that means exactly, that just means if the converse is a true statement, the inverse will also be a true statement. It's a guarantee. So even though it's a different presentation, they have the same meaning. And the same goes here. Conditional, contrapositive, they have the same meaning, even though the presentation is a little different. So if the conditional is true, so is the contrapositive. But there is no tie between these. If the conditional is true, we don't really know what the converse is until we read it and analyze it. So there is no connection between these two and these two down here. but the guarantee does lie within these pairs. They always have to match in truth value. Okay, so that's what we're going to practice here, is this idea of logical equivalence, and focusing in that the conditional and contrapositive are two statements that make the same claim. So let's look at some cases here where we can apply this idea of logical equivalence. Okay, so just some recap here. What we're going to do today is we're going to see some conditionals, some claims that are made. So the conditional statement right here is always from P to Q. Okay, so we're going to see a lot of those, and what we're going to do to analyze these situations is we're going to treat this statement as a rule. Okay, so it's something that we are going to work with. It's a rule that we're given, so whether or not we necessarily agree with it, we're going to consider it to be true. Okay, so whatever the conditional is, we're going to work with that as if it's the condition that we need to apply. Okay, so the conditional here is if a car is blue, then it is beautiful. Okay, and so for us, that is guaranteed truth. That's the rule we're given. We're going to consider this to be true no matter what. Okay, so just for some practice here, if we rewrite a statement as the converse, which starts with the second half Q and ends with the first half P, and remember we're going to keep the subject always in the first half here, we're just going to write this as if a car is beautiful, then it is blue. And so we have to pause to think about this. Is this a guaranteed truth based on our rule, and only based on our rule? So the rule we were given, the condition was, if we have a blue car presented to us, we should consider it to be beautiful. Now this one has changed the order, and the order that we say things could affect how we interpret. This converse states, if a car is beautiful, then it is blue. Well, does our original conditional really guarantee that every beautiful car is going to be blue? Or is the conditional just saying that we should know that a blue car is beautiful? And I'd say it's that second one. All we are told is that a blue car is beautiful. We don't know anything about the other colors. So in this one, when the converse says if a car is beautiful, then it is blue, well, yes, it could be blue, but that's not a guarantee for us. And because it's not a guarantee, we're going to consider this to be false. And you could give a counter example such as a red car could be beautiful, something like that. But we do not have a guarantee that a beautiful car has to be blue. Okay, all we know is that blue cars will be beautiful. So no guarantee here. All right, so we try the inverse then, and remember the inverse. The tilde, the little squiggle here, just means use the opposite of what was stated. So the opposite of P ending with the opposite of Q, and we see the opposite of P was a car is blue. Sorry, P is a car is blue, so the opposite would just simply be a car is not blue. So we have if a car is not blue, again, keeping the subject in the first half of the sentence here, then let's see, now we need the opposite of Q. Q said it is beautiful. The opposite would be it is not beautiful. And so here we go again. We're going to interpret this based off our rule that we were given. And our rule was a blue car should automatically be considered beautiful. And that's all we know. Now, the way this is presented is we know that the car is not blue. Okay. But is that a guarantee that the car is also not beautiful? Well, it's the same reasoning as above, right? Just because the car is not blue doesn't mean it's not necessarily beautiful. We don't have that information presented up here. All we know is that blue cars are beautiful. We don't know anything about other colors of cars. So when this is telling us that we're going to talk about a car of a different color other than blue, we don't really know what to say about that car because we have no information given about it. And so maybe this particular car is not beautiful, but it also could be. We don't have enough information to make that claim. And if you recall, the converse and the inverse right here are logically equivalent. So if we said one of these was false, the other also has to be false. Okay, so the last statement we've practiced is the contrapositive, which just takes the opposite of Q and ends with the opposite of P. And the two ways you can write this is either just reverse the order of the inverse here that uses those opposite ideas, or take your converse, which is already starting with Q and ending with P, and just say the opposite of each half of it. Whichever way you approach, the statement should read, if a car is not beautiful, then it is not blue. Okay, so we have the contrapositive. Now it's time to interpret that. And as we read it, here's what we were given. We're going to compare it to what we know. We know that a blue car is beautiful. That's a guarantee that we were given in the beginning. So here we know now, according to how this is written, that whatever car we're talking about, it is not beautiful. Well, if we know that the car is not beautiful, is it safe to make the claim that the car is not blue? And the result here should be yes, because in the beginning we were told all blue cars are beautiful. And so if this particular car is not beautiful, it cannot be blue because we know better according to the rule that we were told. Okay, so the order of statements matters. It drastically could change what is being said and how we should interpret. But notice again here, the conditional and the converse are always going to match in truth value. They are logically equivalent. And we can use that idea also to help us interpret. If it's easier to read one statement and we can interpret that as true or false pretty easily, then we can automatically apply that claim to its corresponding statement. So if this was easy to read and understand as true, then even if this becomes more complicated to read, we are going to know that it should be true as well. Okay, so what we're going to do is continue on with this example, build upon it. And down here we have a few other examples that talk about this car and apply this rule. And what we're going to do is we're going to utilize this idea that of when a statement is guaranteed to be true and when it's not. So again, if we're given a condition such as this that starts with P and ends with Q, the conditional will be considered true, but the only other statement that is also guaranteed to be true is the contrapositive that can be made. These other two, the converse and inverse, could be true. They're just not a guarantee. And we only want to make claims that are guarantees with deductive reasoning. So down here, we see 4 examples. They all have the same condition. If a car is blue, then it is beautiful. Okay, the same condition we were given before. And so we're going to consider that to be true. And then what we're going to see is that new claims are made. And our goal is to figure out, is this claim leading to a valid statement, a guaranteed statement that we know must be true? It's a little tricky to get used to. What we're going to do is we're going to use our symbols that we know, with our P's and Q's. And our goal is to really analyze if it's a true statement, then we should be able to finish the thought. But if it's not a guaranteed truth of what's being said isn't a guarantee, we won't continue on. We're going to put the letters NVC down, meaning no valid conclusion, meaning we don't really know how to interpret it. Maybe the statement will be true, maybe it won't be true. Okay, so to help us out here, I am going to label the statements that we have. So in all four of these cases, I'm going to label statement A as P to Q because we have our conditional set up as if this, then this. Okay, so I have those labeled, and this really can help, especially for those of us that need the organization, because it's not very easy for us to interpret these claims on our own. So let's use these symbols to help us out, and I'll show you how that works. So keep in mind, every conditional starts with the hypothesis P and ends with the conclusion Q. So the theme of P is about a car being blue. The theme of Q is about a car being beautiful. So what we see here is we have a claim that's being made, or we have something that's being told to us, and we want to know if there's a claim that we can make from that. So in part B here, the statement that we are given is that Joe's car is blue. So we are just given some information about Joe's car. We know Joe's car is blue. So based on what we know from what we were given in the conditional, do we know anything else about Joe's car? Well, the answer is going to be yes, because we know all blue cars are beautiful. And so we're going to end up saying here that Joe's car is beautiful. We're not talking about anybody else's car. We're going to be specific here. But that's all we know. We don't know the brand of the car or anything like that. We just know that because Joe has a blue car, we are supposed to consider that particular car to be beautiful as well, based on our condition. And so when we say Joe's car is beautiful, that is the theme of Q. And the reason this was okay, if you start with P and end with Q, that's the symbology for the conditional. Well, the conditional is what we started with right here. So if the conditional is considered to be true, then any rewrite of that conditional is also true. So if we start out knowing a car is blue, we should be able to say it's beautiful, and that's exactly what we did here. We knew Joe's car was blue, and so we were able to say Joe's car was beautiful. So a valid claim here, a guaranteed truth based on our rule. So then we can look at Mary's car down here. So again, we have our original conditional that is considered to be true. So this is what we're given to work with. If a car is blue, then it is beautiful. Well, here's what we know about Mary's car. What we're being told about Mary's car is that it is beautiful. And that is all we know about Mary's car. And so the thought becomes, is there any guarantee claim we can make about Mary's car, if that is all we know? And there might be some speculation here, but there's not necessarily a guarantee, right? Maybe Mary's car is blue because we know blue cars are beautiful, but we don't know if other colors are also considered beautiful. So this is a time where we're going to put no valid conclusion. We know Mary's car is beautiful, but we don't actually know what color that would be. Could be blue, could be something else. And so there's a reason for this as well. Look here, we have statement B referred to the theme of our conclusion, Q. Well, in all statements that we make, P's and Q's get matched together. So whether we use opposites of P's or opposite of Q's, if we're going to start with a Q, then we are going to end with a P. And the statement that goes from Q to P is called the converse, if you remember. And there is no guarantee that the converse and the conditional are going to match. Because remember up here, we said the conditional and the contrapositive are logically equivalent. but there is no connection between the conditional and the converse or the conditional and the inverse. And if there's no guarantee, then we won't make a claim. So that's one of those cases. The converse is not a guaranteed true when the conditional is true. So we won't say anything. We don't know what color Mary's car is. So we look at case 3. It says, if a car is blue, then it is beautiful. Okay, so again, that's our setup. We know that condition, and we will apply it as we can. What we know about Mike's car is that it is red. So let's interpret this. What does it mean to say Mike's car is red? What is it referring to? Well, that's a color. And statement P, the hypothesis, was referring to the color of a car. So if P is talking about a car being blue, if we say Mike's car is red, that is not blue. And so we're going to represent this as the negation of P, so the opposite of P. And if this is starting with the opposite of P, if we're going to make a claim, whatever that claim is should refer to the opposite of our conclusion Q. Well, let's think. We know that a blue car is beautiful. Do we know anything about red cars? Were we told red cars are ugly? Were we told red is also beautiful? And in this case, no, we don't. We don't actually know anything about any other colors of cars. All we know is that a blue car is beautiful. And so since we don't have any information to tell us how to interpret what to say about a red car, this is another case of no valid conclusion, that NVC. No valid conclusion. Maybe this car is beautiful, maybe it's not. And the reason for that, think this through. We have a statement that starts with the opposite of P and ends with the opposite of Q. That's called the inverse. And according to our logical equivalence, there is no guaranteed truth between the inverse and the conditional. Maybe they end up matching, but they are not logically equivalent. Okay? So that is tying in again why we won't make a claim here. There's no connection between the inverse and conditional as far as logical equivalence. So while we might be able to speculate a claim about Mike's car, it's not going to be a guaranteed claim that we can make. And that's what we want. We want the guarantees only. Okay, so the last case here that we have is about Nick's car. So we still have the same condition. We're going to try to apply it. Let's interpret what's being said. So in part B, it says Nick's car is ugly. Okay, so what is that referring to? We know that a blue car is beautiful. So when we say something is ugly, that seems to be tying along to the theme of being beautiful. Now, it's not the same as being beautiful. This would be a case of not being beautiful. So Nick's car is ugly. And if we're going to make a claim, whatever that claim is, would have to be the opposite of P if we're allowed to do that, because that is how our logic is working. We'll start with a P, end with a Q. We'll start with the opposite of P, we'll end with the opposite of Q, or vice versa. So is this a case where it's okay to make a claim? So let's think this through. We know a blue car is beautiful. So if Nick's car is ugly, is it guaranteed? Is there some kind of guaranteed claim about the color of the car? Well, in this case, I'd say yes. If we know Nick's car is ugly, then we should know that Nick's car is not blue. And that is the opposite of statement P. Okay, and let's think about why that's okay to say. Well, a blue car has to be beautiful. Okay, that's the condition. And so if we know that a car is not considered to be beautiful based on our rule, there's no way that that car is blue. Now our logical equivalence helps us out too, because the statement that starts with the opposite of Q and ends with the opposite of P is called the contrapositive. And if we go back and check this out one last time, the contrapositive is logically equivalent to the conditional. And so if you know the conditional is true, the contrapositive is really just a different way of stating that information. So it also has to be true. So any statement that starts with the opposite of Q and ends with the opposite of P, we should know is also true. And that is what has happened here. We have this conditional that we had this information that started us with the opposite of our conclusion, so we were able to end with a claim that referred to the opposite of our hypothesis. So there's the four cases. We have two cases where it is okay to make a claim and two cases where it's not. It's all dependent on what's being said and what order it's being said. So if we're given information that allows us to make a claim based on our conditional, great. But if we're giving information that's going to make us a claim based on our converse or our inverse, we can't do that. But if the information we're given in part B is going to lead us to making a claim that refers to the contrapositive, then that is okay because of logical equivalence. So there's one last case here. It is called the Law of Syllogism, which you don't need to memorize, but you're going to see is slightly different from what we just did. Not by much. You still have a statement, a claim that's being made that we'll consider to be true, that says if rain is falling, then the grass is wet. Okay. And on something like this, I think that makes sense to us. We have our first half and our second half. So if rain is falling, then the grass is wet. Perfect. So that is a conditional because we have if something, then something else. Now what's different here is you see another conditional in statement B. It says if the grass is wet, then the night crawlers come out. Okay, so let's look at this conditional here and what's being said. The first part says if the grass is wet. And if we just look back to our conditional, that idea was already used up here. We labeled that idea as Q. So the second statement is starting with the theme of our conclusion, Q. Then it goes to a new thought. Then the night crawlers come out. Okay, so following our alphabet, if we have a new theme, we're going to represent it with its own letter, and the alphabet, P to Q, the next letter would be R. So Q to R would be the symbols we'd use for this one. Okay, so that's the first time we've seen that, and we're not going to see it often, but that's the idea, a new conditional with a new idea, so we use a new letter. Now the question is, can we make a claim? So think it through for a second, pause the video if you need. But here, if you follow what's happening, we're starting with a first idea, P. We're ending that one with a second idea, Q. But the second statement starts with that same idea and leads us to R. So if P can lead us to Q, and we also know that Q can lead us to R, so we have two true statements here. Okay, so if it's okay to say this and it's okay to say this, then it must be okay to go from P directly to R. Because it was okay to start with P and go to Q, and it was also okay to start at Q and go to R. So in reality, we can start at P and end at R. And I put a Q there. Let's fix that. And we'll just kind of cut out the middle theme. So the end result truly here is that if rain is falling, then the night crawlers come out. Okay. So that is just one little case there. That's different from what we had said on the front, but I'm hoping it kind of makes sense. The idea here was we had a guaranteed outcome. When we start with this first idea, eventually that last idea will happen based on what we're given. We were told that rain will falling will make the grass be wet, but we're also told that if the grass is wet, this has to happen. The night crawlers will come out. And if both of those are told to us and we assume that they're true, then our starting idea should lead us directly to our ending idea. So also true. And that is the only setup that we can use this for, where we end the first theme, the first conditional, with the same thing that our second conditional will start with. And so down here at the bottom of the page, it's just kind of a recap of everything we've said. There's that law of syllogism right over here. So this is just kind of a table letting you know when is it okay to make a claim and when is it not. So in the law of syllogism, if you have a statement that goes from P to Q and Q to R, it's okay to make another claim that just simply starts with P and ends with R. For the front page, that's called law of detachment, which we never formally said, but that is the description there. It's really just using this idea of logical equivalence. When is it okay to make a claim? Well, we know that the original is always true, right? And if we're going to start with P and end with Q, then we're really just restating the conditional. So this is okay. In a case where we start with the opposite of P, so that was missing, the opposite of P, we cannot end with the opposite of Q because that would be a case of inverse, and the inverse has no logical equivalence to our conditional. Same happens down here. If statement B refers to the theme of Q, this would lead us to the converse, which is also not logically equivalent to the conditional, so we will not make a claim. There's no guaranteed claim there. But at the end, we have the opposite of Q being said. So we have our given information. The next statement says something about the opposite of our conclusion, and it's going to lead us to being able to make a valid claim that refers to the opposite of our hypothesis P. And if we have that, we can make that conclusion because the opposite of Q to the opposite of P, that's called the contrapositive. And again, the contrapositive is logically equivalent to the conditional. And so it means the same thing, it's just stated in a different way. So we have a valid conclusion that can be made there. Okay, so now you're going to get a chance to practice, and that's the whole idea you're going to use is there a truly valid claim that can be made? Even if the statement that you're given is just totally nonsensical, you will be given a rule that you can apply. And so read carefully, think carefully. Do I have a guaranteed claim that I can make? If so, do that. If there's not a guarantee, we shouldn't be making claims, because what we want to practice here is using guaranteed truths to work through a situation. Take some time to get used to. Be patient. Look through your notes when you need. Ask questions when you need. Good luck.